Welcome everyone to the second episode of the MEAM Faculty Spotlights in American Society of Mechanical Engineers. Thank you so much for the folks who tuned in last week where we interviewed Professor Dustin Roberts. We were doing frequent faculty spotlights, highlighting the professors that you might have taken classes with, done research with, or that you haven't even got the chance to talk to yet.
My name is Jason Friedman. I'm a junior studying MEAM here at Penn. I'm originally from Yardley, Pennsylvania, which is actually where I am now. I'm joined by Adam Liang, who's also a junior studying MEAM at Penn. And one of the main reasons that we came to Penn is because there's amazing world-class faculty here doing amazing research and also just engaging with students in ways that we couldn't even have imagined before coming here. These professors have really become more than just teachers to us, but honestly mentors and people who we look up to as we follow our own path towards adulthood and careers in engineering. So without further ado, today we're joined by Professor Jason Raney, a professor in the MEAM department who is willing to take the time out of his busy schedule to talk to us today. Adam and I are currently taking MEAM 321 with him, a class in vibrations. And Professor Raney has been really interactive despite the virtual academic setting that we're all living in now. But beyond that, we're really just curious to learn more about him in the non-academic setting. So that brings us to the present. Professor Raney.
Yes, thanks so much for the invitation. I'm glad to be with you guys. And we have to be creative in how we can interact these days. It feels a little bit like there's a light at the end of the tunnel in terms of the whole COVID scenario. I certainly hope so, as I think now an entire year has gone by, and I never thought, I guess, that it would be this long a year ago, but here we are. So thanks guys for taking the initiative to put the series together and helping to foster these conversations.
Yeah, now that I think about it, I mean, we're reaching the 1-year anniversary mark for the pandemic. But anyways, getting into it, I think the first question we just kind of want to know is a little bit about your background, where you're from, I guess, what you studied, which universities you went to, graduate degrees, as well as maybe a fun fact that people might not know about you. I think something that we're really interested in learning is the story behind the Mohawk picture that you showed us during class. To the folks listening, Professor Raney showed us a picture of him in a Mohawk, I think from his younger years during one of our classes. So that's something we'd love to touch on.
Yeah, that picture, just to clarify, that picture was from like 3 months ago. So I grew a big Mohawk during the fall, and that was just my the way in which it was a coping mechanism with the long isolation of the quarantine. The fact that I can't grow a nice beard, like it just never has looked good when I've tried. So I knew a lot of guys that, quarantining, I'm going to grow a quarantine beard. And so for me, the best I could do was a quarantine Mohawk. I tried to mostly keep it kind of sideways and down to be polite when I was meeting, in a professional capacity. But it was it was one small thing that I could do to cope with the difficult year. I think that, it was the pandemic in part, but it also just seemed like so many other challenges, and both, culturally, but also personally. Like I know a lot of people that died in 2020. I mean, not to sound like horrible, but and some of that was COVID, but a lot of it wasn't. Just friends who had been had a disease that they were fighting for a long time that succumbed, and so it just felt like a really dark year. And I think it also instilled some gratitude. I think I felt grateful, but I also felt like I needed to have some kind of edge to that year to sort of recognize how difficult it was. So on New Year's Day, we cut off the Mohawk, but it could come back. I enjoyed it enough that I haven't ruled it out for the future, at least. So
I can actually relate with that in a couple ways. For one, on the lighter end, I too have been experimenting with my hair. I guess, Professor Raney, you only know me over the past couple months, but Adam knew me back prior to COVID when I had normally length hair. But I've been growing it out since quarantine began. And so I think I'll get a cut on the 1-year anniversary, which is like next week. But yeah, experimenting with hair is definitely a good way to cope and to stay interested. And then I guess on a more serious note, in regards to your point about how it kind of makes you more grateful, I think that's a great perspective, and I've really tried my best to share that. I heard somewhere that or I heard somebody say to me that they thought 2020 would be the year that they get everything that they've been hoping for. But then they realized that it was actually the year that they appreciate everything that they have, you know, and that really took me back, because like everyone always is fighting for the next thing that they can maybe get in life. But really there comes a time when you have to just appreciate what you have, because you never know how long you'll have it. Even seeing people in person is a gift that we never knew would be taken from us, you know. So it's good to appreciate things that we have. So I was really interested to hear you say that. So I guess moving on to another topic, in terms of career trajectory. So we know you as a professor, but as Adam mentioned, you know, we're sure you come from a background with a lot of other interesting things. So I guess, what got you to this point, and did you always know you wanted to become a professor, or was this kind of just the most recent step on an otherwise filled journey?
Yeah, it's a good question. So certainly no, I did not always know that I wanted to be a professor. I think so. When I was an undergraduate student, I didn't even know what research was. So I had my dad, who's a very, very smart guy. He never went to college. He has a high school education, and he was, you know, drafted during Vietnam, and, you know, became an, you know, aircraft mechanic for a while, and then became a self-taught programmer and did all this stuff later on, and he's had a good career out of it. But he didn't have that formal education for me to even know what it was. And my mom studied like elementary education, so she had an undergrad degree at a little liberal arts school. So, but from her experience, all I knew of college was just like the purpose was to get some training, to get a job. And so when I went to the University of Minnesota for my undergrad degree, which was pretty nearby where I grew up. And like I studied physics because it was just interesting. Like I took physics in high school and it was easy. Like I was good at it, and I'm not good at a lot of things. Like I tried like rock climbing and I was horrible at it. So I was like, well, it's not fun to me and I'm bad at it, so I'm not going to do that. And physics is really hard for some people, and I find it like comfortable. So maybe since I don't have a strong passion at this moment of what to study, maybe I should do that by default. And then, you know, as my dad was a programmer, and so I knew I could get a job if I studied computer science. So I studied computer science as my practical degree, and I studied physics as my interesting degree to me. And that's how I went to college. But I didn't know what research was. So I just went there to get training in those areas, basically. So, you know, that brings up one theme in terms of, I think in my life has been learning through iteration, learning about, I try something and I don't like it. And then in addition to that, it's like, well, is it something I don't like, but I should learn to do anyway, because it's a good thing? Or is it something I don't like and it doesn't matter if I learn it, in which case then I don't bother anymore with it? So like, for example, I used to be terrified of public speaking in high school. Like I think of a presentation and I'd be like panicking about it. And now it doesn't bother me at all. Like it's just not a thing. And I knew that was a fear that I had to get over, because that's important no matter what job you do. Like no matter what you do, you have to be able to communicate publicly. And so you should learn that. We all should learn that, I think, no matter what we do. So that's just a couple of quick examples, but that same theme has been a large part of my professional trajectory, has sort of been ping-ponging off some things of like, oh, this sounds like an interesting idea, and I try it, and I like some element of it, or I dislike other elements of it. And that's just new information about myself that I learned to make a better decision with the next iteration. I have known people that I envy who have had this passion since they were like 4 to do a particular thing. I have a couple friends who always knew they wanted to be vets, and they became vets, and they like it, and they've been happy pushing toward that target, and they achieved it, and they're happy in that trajectory. And I just don't relate to that. Like I've never had that sort of knowledge from youth of some particular trajectory that I want to do. So yeah, I don't know if that's the big theme about that is just one of learning through trial, I guess. And I you know, that's something that I hope everybody can appreciate. And I don't think that there's as many people in the world who have this one particular passion from a young age as maybe we are led to believe. So don't give up hope if you don't know what your passion is. Just keep trying things.
Yeah, I know I was certainly coming into college, I kind of had this idea of this path I wanted to do, right? You know, try to find an internship, do research, and then work at an industry doing engineering work. And then I realized that like I just fundamentally had no idea how I was going to do that. You know, I've seen people on LinkedIn, I've heard of people that come talk at panels and talk about their specific career path, and it's always really winding, right? And I really appreciate kind of the theme that you're talking about, is it being iterations, kind of like an ebb and flow, right? Maybe I like fluids more than I like controls. I'm going to follow that. And that's exactly what my mindset has been. And I think a lot of freshmen, like freshmen out here that are hearing this, it's okay if you have no idea, you know, how you're going to get to point B from point A. Like you don't need to, you know, follow a set path. But it's also good to talk to people like your advisor, whether it's a professor advisor or maybe an upperclassman like me or Jason. You know, we all have very different paths. But the moral of the story, as Professor Raney's been saying, is just kind of go with what you love. If you love physics, do that, right?
Yeah.
So I really appreciate that.
The thing I'd add to that, one thing that I have found incredibly helpful through that process is to be doing it while you're surrounded with really good people, right? And you become like what you surround yourself with to some extent. And I have been just profoundly struck by how being around people who are smarter than me is really inspiring. Like you observe what they're doing, and they might have talents that you just don't have in certain ways, but still being around that, even if you can't do what they can do, inspires you toward setting high goals and trying hard. And that to me is more important. Who I'm doing stuff with is more important to me than what I'm doing, if that makes sense. The quality of the people. And that's partly what ultimately led me toward a career in academia, is feeling like I'm surrounded by really hardworking people with really unique, not just unique professional, you know, research type abilities, but
right.
a lot of times people of that kind have some really interesting personal qualities as well, in terms of things they enjoy doing, or sort of unique, unique things about them. So yeah, being around people who have some kind of passion. Maybe I'm kind of like a passion vampire, in the sense that since I didn't have this passion from when I was like 4 to do something, being around people who are passionate about what they're doing makes me feel excited when I'm around people who are excited.
And do these people usually come in the shape of mentors?
I honestly, in my experience, it's been more likely to be peers.
Right.
Not
Peers.
always, but it helps, because a lot of times it's someone in a mentorship relationship with you who's kind of setting the culture where you're at. So I think back to my previous advisors, before coming to Penn, most recently my postdoc advisor, who's Jennifer Lewis at Harvard, and she's actually coming in a couple weeks to give a talk in bioengineering for anyone who's interested. But extremely talented mentor who sets an incredibly high bar of excellence. And so, yeah, in that sense, yeah, she as a mentor was setting a really high standard, but then that led to a whole research group and a whole environment of excellence that I found inspiring, seeing my peers working really hard, asking tough questions, and holding each other to high standards. It's really easy to be intellectually lazy if those around you let you be. Right. Especially if there's sort of confirmation bias, where you kind of all agree about what the outcome should be anyway, then you let each other slide on the rigor. And being challenged by, even if something seems like it should obviously be true, but someone forces you to really assess why, that'll make everything stronger about you, and refine your beliefs.
So, yeah, always challenge the status quo. And I've heard that phrase throughout the entirety of my life.
Yeah, and I feel like in a nutshell, that's one of the beautiful things about Penn. Penn takes a lot of students who excelled in high school and maybe weren't challenged as much, or didn't have people who made them feel like dumb, and it makes them feel dumb. It puts us around other people who are, intellectually like challenging to us, will put us in situations that we're maybe uncomfortable in. And it really makes us grow from it. Like I think at Penn, like I'm not learning because I'm getting everything immediately. I'm learning because I'm not, you know.
Yeah.
And professors like you
Yeah.
help push us and remind us of these lessons, and then also teach us the technical skills that we need, you know, whether it be under dam systems or whatever else have you. Like I think really just learning from what we don't know is just a great lesson to have.
Yeah, and being humbled like that, as you suggest, and I'm glad you pointed that out too, because before, when I said high school physics was easy, it doesn't mean that everything since then was. High school level physics was easy for me as a high school student, but then you went on, and I ended up doing my PhD at Caltech, and it felt like I was being punched in the face every day, and like I was barely hanging on, and I thought I was going to fail out. And so yeah, if you think everything in your life is easy, I think it means you need to find circumstances for yourself that will make you not feel that way anymore. And that's how you're going to know you're growing. And that's another thing about academia is I have found it for myself that I kind of need, I want to succeed, but I need to do things that I have a realistic chance of failing at. Like I need that external motivation. And so, I kind of want, whatever I do, I need like a 20% chance that I really might not succeed. And
I love that.
That's kind of exciting to me about what research is. That's one of the draws to it, because we try all these ideas, and it's not like we're trying randomly. We're not going into the lab and doing trial and error, because don't do that. That's not good experiments. That's not good science. But we've learned a bunch of stuff, and helps us to make reasonably good hypotheses that we try, and then we test them. And a lot of times they're totally wrong, and we learn something new. And that's what I like about research. Sometimes you find you kind of think you understand the foundation, and so you propose some ideas, and sometimes they actually work. Like you try them out, and you're like, oh yeah, everything happened that I thought was. It's like, okay, you check that box. But most of the time, that's not the case. So there's always these unexpected things that happen, and things aren't so obvious. Yeah.
Yeah, I just, when you say that, what I think of is kind of this idea that I've had in my head for a while, that if there's no such thing as failure, then there can be no such thing as success, right? Like they are each other's opposites. And if you always succeed, you always do things you know you can do, then at that point, what's the fun? Like, you have to be able to fail and accept failure and learn from failure in order to make the successes more valuable. So that's just something that I think that we both kind of been thinking along the same lines there. And I was really interested to hear you talk about that. But I guess delving further into your research, I guess the abstractions that you've talked about, like what makes research in general interesting, were really interesting to hear about for us. But more tangibly, could you just speak a little bit more to the lab that you have and the research that you do specifically with students?
I'm sure many students will be interested in just hearing about that side and opportunities as well.
Yeah. I think so. There's a lot of different things we do, but I think the one theme that kind of relates all these pieces together is there's a couple analogies I can make. One is, if you could think of like Star Trek, and I grew up like in the 90s, and so maybe people don't understand these references anymore, but like in Star Trek The Next Generation,
I don't know Patrick Stewart, right?
Yeah, and I don't know if the other Star Treks they do this as well, because I didn't watch any other ones. But I watched Star Trek Next Generation back in the 90s, and they have these replicators, and so you go and you say, I need like a cup of tea or something, and they like press a button, and like molecularly is this cup of steaming tea that's assembled for you to drink, right? And obviously that's a science fiction thing, but much more tangible is through things like additive assembly, through 3D printing and all these types of things, you can at least get a glimpse at a macroscopic scale of what this kind of is like, where if you just give me some substrate, now I can build on it some 3D structure, one little voxel at a time. We put some material here and some here. We don't put any over here. And then I add some other material B here, here, and here. And this idea of constructing objects kind of in this layer by layer way, almost like some kind of Lego structure, is really interesting to me, because in traditional manufacturing, the way you traditionally make stuff is what we call sort of subtractive manufacturing, machining. You start
like
with
a CNC mill.
Yeah, you start with a block of material and you mill it down, or you start, way back thousands of years ago, maybe you're a sculptor and you start with marble and you cut away pieces very carefully over months to get the shape that you want. that leads to, I think, traditionally, especially among mechanical engineers, maybe a lack of creativity in the types of parameters we might be able to control as engineers. So we think of, I'm going to build a building, and I have my struts and my I-beams, and they have a particular shape. But we don't really think about what's inside the I-beam. We just give me some standard steel with some particular setting, standard properties, and give me the I-beam of a certain shape. But now with additive approaches, we can really control all the stuff inside of that I-beam, right? You can make I-beams and I-beams, I-beams inside of I-beams inside of I-beams, right? And the point is, as an engineer, you can begin to envision a future where you can really dial in properties to make them, for example, very lightweight, where you can make, say, an I-beam that has the same rigidity as the old one, but weighs like a quarter as much. So now you can build taller buildings. Or like in an aircraft wing, now I can make it even lighter because I can, only use material precisely where it helps me mechanically. And that's kind of the first level of this. But then you think about other properties. So that's just like stiffness and mass. But you can do things like, if you think of like nature and tree branches and bone and all these kinds of things, if you try to break a tree branch and you eventually succeed, you find very complex fracture patterns. It doesn't just snap like a piece of glass in a very straight line. It has these very complex features to it that are associated with its internal structure, even defects inside the structure that lead to these very complex patterns. So we're interested in harnessing these kinds of tools to ask questions about things like failure. Like, if I can put material anywhere I want, how can I make a block of material that looks the exact same as the other block of material, but when I break it, dissipates 10 times more energy? Or also a lot of what we do relates to dynamic properties. So if I can make something that just looks like a block of material, but I hit it with a hammer, and instead of the traditional pulse that propagates through as we might expect, what if the force is split up spatially into separate modes and arrive at different times? So there's a lot of things like that we can do where we sort of blend material and structure into a single kind of concept. And that's probably the best I can do in terms of explaining the basic theme of the lab. And so within that space, there's a lot of applications you can imagine, from all the way from just trying to make lightweight protective structures to robotics kind of on the other end. It's sort of functionality.
So is this lab very interdisciplinary? Is it mostly comprised of mechanical engineering graduate students and postdocs, or is there? It seems like there would be an obvious intersection between material science engineering and mechanical engineering.
Yeah, absolutely. And I think the more with each passing year, it sure seems to me like departmental boundaries mean less and less, not just at Penn, but as disciplines. That a lot of interesting things are happening at these interfaces between disciplines and between multiple disciplines. So my PhD is actually in material science. And here I am in a mechanical engineering department, and it's sort of, but my lab is in LRSM. It's in the material science building, and it kind of, so I have mostly mechanical engineering students. I have some material science. There's actually a master's student I have who's in bioengineering. And yeah, it's very interdisciplinary, and that's where I think it's more exciting as well, doing interdisciplinary problems rather than, I think historically there was much more of a tendency for people to really silo into one thing and be like the world's expert on one particular thing. And, due to the complexity of knowledge and science, that's still true. We do have to specialize because none of us can learn everything. But I think they come together. Yeah, there's much more conversation across these boundaries, I would say.
And I think you see that happening in a lot of industry too, like R&D departments at large companies like Boeing or SpaceX, Tesla, like they're largely interdisciplinary, right? Maybe there's the battery team, right? But it's composed of mechanical engineers and electrical engineers, when in previous, decades, it was mostly all electrical engineers. So it's amazing to see that there's kind of that interdisciplinary effect happening, not only in academia, but in waves in industry.
Right.
Yeah. Sorry, I was just saying that's also great to hear, because especially in the COVID era, when it's very hard to stay connected, we think of, in the professional setting at least, like there really is no separation in the first place between people of different, academic or professional backgrounds. Like the fact that MSc or, MEAM students and faculty can be working together is really great to hear. I personally actually came into Penn also interested in physics and computer science, kind of relating back to your background you had discussed earlier. And I had a concern like, oh, well, how will I have to pick one and then like never do the other again? And I've been happy to see that that's really not how it works in the real world. Like you're always doing multiple things, which is great because a lot of people like all three of us, for example, have interests that, you know, cover a lot of like a really broad range of different areas. Like robotics is computer science and physics, like you had said, materials and mechanical engineering. Like there's so much overlapping industries that it's great that you'll never really have to just like pick one. I guess transitioning to another topic. So we know you in the capacity of our professor for MEAM 321. But you know, we're a little bit curious, I guess, from your end, like how you approach these lectures coming in. Like for anybody listening, every Monday at 3 p.m., Adam and I look forward to our vibrations lectures from Professor Raney. But Professor, we're
You're
just
very
curious,
kind.
like,
No, it's true.
when you come into a lecture, what are you thinking? Are you excited or nervous or confident, or what's going through your head usually?
Great question. I think the more time that goes on, the more it is just suddenly a desperate context switch, because it's the one thing about faculty, the career path that we're all on here as faculty, is that we wear lots of different hats. And
right.
The longer you do it, I think the more that's true, the more you're pulled into additional, you know, deliberations, different committees to do a lot of different things. And so we pack a lot into every day. And so teaching in a way is an exciting time because it's finally something that's kind of has some extended time to it. Like I minimize all my, like my email is shut down. Like I don't have to see my email for an hour. Like that's cool, because otherwise there's always things that pop up there. It kind of, you have to shut all that down and then just focus on trying to make a coherent discussion for people to be able to follow, to try to communicate sometimes difficult technical information. So in that sense, it's like it's a positive, enjoyable thing to get back. And it also is fun to get back to really the fundamentals of the discipline. In a usually a more coherent way. There's like a story, like an order to it in terms of learning these foundational principles, which is sort of, it's, in a way, it's kind of calming in an otherwise crazy world that you're running around between things in. So I mean, immediately before class, what I'm doing is just trying to like mentally switch contexts to that mode, away from, you know, whether I'm working on writing a proposal or I've just been talking to a student about some problem we have in a manuscript, or some research data that they have that doesn't make sense, or a faculty meeting, whatever it might be. That's maybe one of the harder challenges for me, where I like to pursue an idea, and instead most of what I do is have to switch between contexts all day, and so it always takes me a few minutes to kind of clear my brain again and get into whatever the new context is. So that's probably evident in my lecturing style as well. If the beginning makes no sense until my brain finally like coalesces around the principles that are being discussed.
I'm so glad that you described it as calming. I'm also a tour guide for Penn, and one of the things we talk about is how we're a research university, and a misconception is that professors only do research. But professors like yourself, like you're involved in research, maybe 50% of your time is involved in that. But you know, the other half is advising and dealing with undergraduate students. And the fact that you obviously have this love for teaching, and that it's somewhat of a mental exercise or mental switch from the research side to the teaching side. It's really amazing to hear that. And I'm sure that we could say that for every professor and the ones that we're going to interview, you know, throughout the semester. So
yeah,
pretty cool.
I think it might be why there is a stereotype of absent-minded professors, and you know,
right.
I think there's some truth to it, but it is partly because of this always context switching, and so you see them in the hall and like they're thinking about something, and then now they're, oh wait, now there's someone talking to me, and so you know there's a lag sometimes in the context switch that probably leads to this natural kind of forgetfulness and absent-mindedness, leaving car keys behind all the time and stuff like
that. Yeah, it is funny you mention that, because like I do research in Dr. Cynthia Sung's lab, and so I know her in that context of my robotics boss, so to speak, right? You know, she's my employer there. But a lot of my friends know her in the context of Engineering 105. And so it's the same person who me and like Adam, for example, might know in a completely different context, which is just really interesting to then like getting the chance to talk to you, you know, one-on-one here. You really get a sense of what it's like to be that person who wears those multiple different hats, as you said, and kind of has to simultaneously, you know, perform up to the standards of their students in the research lab and also students in class. And then just another comment I have is that it's just great to hear that you think of teaching kind of as like a break, so to speak. Like a lot of people, I think, will think of their break from work as like watching TV or like
right.
playing basketball or something. But to hear that teaching is something you really feel passionately about enough and you enjoy enough, like being there with us, that it's your like break, is just honestly really like something I'm happy to hear, given that I'm there learning from you. It gives me confidence going into class that this person really loves doing this enough that this is what he considers leisure. So I'm just really happy to hear you talk about that.
Yeah. I think one of the ways to define passion is, I mean, all of these, you know, when I went through the college admissions process, they always ask this one question, like, what's one thing that you do where you lose track of time? And I think that's a perfect definition of what passion is. And I'm sure you experience that when you're teaching, or maybe when your office hours goes for too long. You know, I'm sure that's happened many times because you're just kind of stuck, you know, in the weeds with helping a student with a particular problem. And
that's certainly the most enjoyable things we do, I think, are interacting with the students, and partly because you see their growth, both in the context of class through a semester, but also through advising and through, same with the PhD students, when we have research meetings with them and you look where they go from a first year to a third, fourth year PhD student, and how much they've grown in terms of their knowledge, but also in terms of their, you know, leadership skills and all these things that develop in this really exciting time of life that you're in, where you're learning a ton of things and you're growing, and you know, embrace that. And it's fun for us, I think, to be able to relive that a little bit vicariously through you, and to discuss your goals and the things you're learning with you, and watch you internalize them.
That's definitely an interesting change in perception for students, because like Adam and I view college as like 4 years that we go to, in my case 3, because this year currently I'm not actually in college, but that's separate. But you know, these 4 years of our lives that end. But for professors, they're there indefinitely, right? Like you have 4 years of my life and then 4 years of another student's life a year after me, and you're really there to see all of us come through that cycle, and you know, really supervise us and watch our growth throughout that process. So it's just interesting to think of professors as being a staple in the university that we might ourselves consider just as a brief section of our life. And I guess delving further into that idea of the growth in students that you like to see over time, that actually transitions nicely into what will probably be our last topic of conversation for today, which is potential advice you have for students. So in terms of facilitating that growth, right? And, you know, Adam and I are juniors, but I'm sure that there are freshmen and sophomores listening who still have a lot of time, even in their 4 years of college, to grow. So what advice would you give them to get the most out of their undergrad degree and really put themselves in the best situation for future success?
Yeah, that's a great question. I think my response to that is framed by my own mistakes looking back, and so I can say what I would do differently looking back at that time. One of those is, I think you need to realize that everybody here wants you to succeed. I mean, there's a reason why faculty are here, and we also know students are faced with a ton of pressure. Students are, COVID, of course, doesn't help at all. But there's a lot of challenges people are facing, and we actually want to help however we can. And I know that it's something, of course, right? That's your job. But I think I felt as an undergrad that the professors were some kind of like distant people that were kind of like, I didn't even go to office hours because I felt like weird doing it. Like maybe,
really?
There are these professors and I'm like, I just need to learn this on my own. And it was just, in one way I learned a lot intellectually by forcing myself to do everything. But I also feel like I missed massive opportunities to get to know people that are really driven and knowledgeable about different things. Not just the faculty, but other staff, and then of course your peers as well, especially at a place like Penn. All of you are surrounded by really interesting and talented people, and get to know them, take advantage of your time with them, and you'll be making friendships that last your lifetime in many cases. The second thing I would say is you have to be able to see setbacks as temporary. I think one of the things that I found most challenging, well, I say one of the most toxic thoughts I think that I was experiencing at that time was when something bad happened, viewing it as a larger setback than it actually is, and viewing it also as something that will last forever. Like, it's easy when something bad happens to like make this like extrapolation from that bad event to the rest of your life and say that all of these other things therefore are inevitably bad and are going to happen to me, or you know, whether it's a relationship or whether it's your studies or exams. I think there's a tendency when we're all at that stage to take a setback as like a personal thing and internalize it in a way that you don't need to do. We all have made major mistakes and failed in different ways along the way, and it doesn't imply that somehow you're a failure when you fail. Like, we all should be trying new things and succeeding at some of them and failing at others, and that's how I learned and grown. But I do remember those moments where some bad event I took on as like, this is a life-changing, life-altering thing, of giving it too much significance. And I think that's a really common. Good. I wish I could help people not do that, because I did it and it didn't help anything, and it wasn't true. That failure wasn't permanent, and you learn from your failures and you become better for it.
Yeah, I think that's a great. Oh, sorry, Adam, go ahead.
Yeah, I was just gonna say, like, an example of that, you know, that I've experienced as a junior applying to jobs, right? A lot of them don't even respond. You know, they don't even give you an interview. And then when you get to the final round, even if you did it perfectly, you did all the technical interview questions, the behavioral questions perfectly, and they reject you, right? It takes a lot of courage to say that isn't personal. That's just something that, you know, we don't know. Maybe it might be a crapshoot, or there's a competitive pool. There's a lot of factors that go into a company deciding to take you. And so I think I really appreciate you saying that it's not a failure. And you have to have those before you even have something successful, and you treat it as an iterative process. So.
Yeah, and then I guess just building off that, like, and really outside the scope of just applying jobs, with failure in general, you know, like you don't want to wind up in a cycle where you fail in one small thing and then you kind of have like a poor self-image, and then you don't have confidence going to the next thing, and so you fail on that. And I think in quarantine especially, this is an important message for students, because people are home, like, not doing a lot, like stuck with their own thoughts, right? So if these thoughts are negative, if you have a small failure that sets you down a dark path, you know, that just causes a lot of unnecessary negativity in the future. And so it's great to really, you know, for you here to remind us that we shouldn't make a lot out of these failures. Something really tiny, or like Adam said, in the context of jobs, something even out of our control, you know, isn't a good reason to then lose confidence and then to lose the ability to succeed in the future. So that's just, I think, a really important message here in quarantine. And then also, you know, just, I guess, to reiterate a message that I had said earlier that I think all three of us here agree on. You have to fail in order to succeed, right? That's how you learn. If you don't fail, then there really is no notion of success if you only ever succeed. So, you know, again, just be willing, and if anything, embrace the failures to any people listening. And then that'll help you get further on your way.
Great.
So,
yeah, that's a good summary.
Yeah, I guess that's kind of a good note to end on here, as we're also coming up on time. So if nobody else has anything to add, then I just want to say thank you to all the viewers listening and tuning into today's episode. We were fortunate enough to be joined by Professor Jordan Raney, and thank you, Professor Raney, for joining us once again. I'm Jason Friedman. I'm joined by Adam Liang, and we're signing off until next time.
Thank you, Guy.
Thanks, guys.
Yep.